Okay, hi everyone. I hope this video finds you well. So, we're going to talk about doubly linked list, and I'm just going to introduce you to it since now you know how the linked lists in general are working. And we're going to talk about iterators and how they work, iterator methods, and finally we're going to conclude this lecture with a comparison between iterator and iterable. So, remember the node in a singly linked list? The node in doubly linked list is just going to have one addition. So the node in single linked list contains data and pointer. Data, one or more data fields, may be organized as structures or objects or anything else. Pointer that points to the next node. The doubly linked list is just going to have one extra pointer. The pointer that points to the previous node. Here's the pointer that points to the next, and here's the pointer that points to the previous, and that's it. So basically, a doubly linked list is going to have dual pointers in all the time. So the head is pointing to the first node is pointing to the second node, and so on. And the last node that is pointed by the tail is going to be pointing at the previous node. The previous node is going to be pointing at the previous, and so on until the first node previous is pointing to null. So the first node previous is pointing to null. The last node next is pointing to null, and that's it. And the current is keeping track of where we're at. So possible node classes, it's just going to add this. And to the constructors, we are going to add this. And if you just want the one with data and next without a previous because you didn't know what a previous yet, and just with the data or the empty node. So that's it. We're just modifying that by adding one extra pointer. We are modifying the single linked list. That's it. So let's now focus on iterator because this is my main focus today. So in computer programming, an iterator is an object that enables the programmer to traverse a container, particularly lists. So various types of iterators are often provided via the containers interface. Though the interface and semantics of a given iterator are fixed, iterators are often implemented in terms of the structures underlying a container implementation and are often tightly coupled to the container to enable the operational semantics of the iterator. So basically, iterators offer a special way of getting sequential access to all elements or entries of a collection. It's some kind like the for each. Remember the for each? The iterate over all the elements in your array? It's something similar to it with extra functions. So the advantages of iterators, counting loops are not suitable to all data structures. Something like linked list, you cannot do counting loops because they don't have indices. You can use that in arrays, but not in linked lists. So you would need something new like iterators to the new data structures with no or slow random access, like again lists or trees. Iterators can provide a consistent way to iterate on data structures of all kinds and therefore make the code more readable, reusable, and less sensitive to change in the data structure. An iterator can also enforce additional restrictions on access, such as ensuring that elements cannot be skipped or that a previously visited element cannot be accessed a second time. So the iterator is an interface. The iterator interface implements these methods, and these are the most important methods. Has next, it checks if there is a next valid node. And next itself, it accesses that next node. Remove is removing the current node. So most Java collections have an iterator. For example, if you want to check the array list, which is something you used a lot, the array list is actually implementing iterable. Iterable is basically doing the iteration on that array list. Iterable. Okay, iterator array list example. So here is iterator demo. If you have an array list of 3 elements. So array list called names, and we have 3 elements inside. The way you would use iterator is basically first, what is the data type in that array list? It's a string. So you would create iterator of a string, right? Iterator of type string. And you can call it IT, whatever you want. This is a variable name. Then you do names, which is your array list, dot iterator. Then you do while the IT dot has next, while this iterator can point to a valid next element. Take that element, store it somewhere, or you can just do system.out.println this. So instead of these actually 2 statements, you can have this, and inside the parentheses of the system.out.println, it.next. That's it. So if you're going to use it on a hash map, after defining a hash map, you can have iterator that would get to the entry set. So iterator equal hash map dot entry set dot iterator. This is going to access all the elements in the hash map. When you do iterator dot has next, if there's a next element, then you do map.entry, whatever you call it, me2 or whatever. You do iterator.next map.entry. And this entry is going to be of key and value. This is why we call it an entry. And then you would get to me2.getKey, gets the key. me2, this variable name, dot get value, gets the value. And again, these names like the me2, iterator, those are variable names. You can choose whatever you want. It does not have to be me2 or iterator. You can use anything. So the interface iterator is having, for each remaining, has next, and methods. And those are the 3 methods that we are going to focus on. Has next returns true if the iteration has more elements. Next is going to return the next element in the iteration. Remove removes the from the underlying collection the last element returned by this operator, or basically where that iterator is pointing at. Okay, so the doubly linked list, we can have a list iterator, and we can have a list iterator with by taking advantage of the previous and next pointers in our doubly linked list. So we can also update the list by inserting or removing from it, right? To add from it. So inserting to the list, removing from the list. So interface list iterator, we're going to call it list iterator, and we are going to provide a few things. Add, has next, has a previous, since it's a doubly linked list. Next, next index, return the index of the element that would be returned by the subsequent call of next. Previous index, remove, and set. Set is basically replacing the last element returned by next or previous with a specific element. So we are going to check some of these functions because these functions are of our interest. So has next returns true because it returns a boolean, returns true if the iteration has more elements, false if there is no more elements. So in other words, returns true if the next function would return an element rather than throwing an error or returning null. So next is returning the next element in the iteration. It throws no such element exception if there is no more elements and you used it. So usually we wouldn't use next unless you're using that inside a while loop where the condition was has next, return true. So you wouldn't use next until you use has next and it returned true. So the iterator on a linked list. So if we have this linked list with those elements, so we have the first pointer points to null, as I said, the last pointer points to null, as I said, this is next and this is previous, and we have head and tail. So the iterator is going to be exactly a node of, it's like current in sync linked list, right? Something like that. So it's the iterator is pointing to this, So has next would be true because does this has next? Yes, it does. It has 5. The node that contains 5. It has a next. Does it have a previous? No, because it points to null. So has next would be true. Has previous would be false. If we move on the iterator, and you can move on the iterator by using next. Next is returning 5 and advances the operator. Next, if you use next, iterator.next, it advances the operator and removing the last thing it was pointing at, which is the 5. So has next would be true because yes, it does point to any to next and it does point to the previous. So yes, both are true. Iterator moved on by doing next. Next returned 22, returned past simple, returned 22 and advanced the iterator. So the iterator now is pointing at 12 and 22, right? Pointing at the node with 12 and the node with 22. So those are both returning true. Then has next is returning false because it points to null, but the previous is pointing to an actual node, so it returns true. This is the next. So again, next returns the next element in the iteration. For example, the next unseen element, which becomes seen element after you use the next. So aliases reference returned by next. So has previous also return a boolean, as we have seen. If it points to null, it's gonna be false. Otherwise, it's gonna be true. So previous is doing the opposite of next. Return the next element in the iteration, and when we say the next from that side. The previous element in the iteration, if we are going to be more accurate than using the word next. So the returns the next element in the iteration in that side, or simply you can say returning the previous element in the iteration. And again, it throws no such element exception if used without has previous, because you were actually pointing at null and you were trying to get a null. So iterator in a linked list, let's see how the previous works. If we're at this point and has next is pointing at null, so it returns false. Has previous is pointing at the node with 12, so it returns true. If previous were called, then it would return 12. It advances the pointer in this direction. So previous has returned 12 and the iterator is moved. And now both has next and has previous are returning true. Same thing if we use that, the iterator is moving on and returning, for example, 22 and moving on. Both are returning true. The has next and the has previous. And eventually the previous is going to be false because you don't have anything to return after you return the 5 and move the iterator. So if I try to call previous now, where previous is actually pointing to null, it's gonna be an exception. No such element exception. So add inserts a specific element into the list. Inserts an element into the list. So add, the element is inserted immediately before the element, and this is very important where the element is inserted. So the element is inserted immediately before the element that would be returned by next, and if any, and after the element that would be returned by previous. That would be returned by previous. So if we were here, if I do add, it's gonna be in here. It's gonna be inside at this point between the 5 and 22. So the new element is inserted before the implicit cursor. Subsequent call to the next would be unaffected, and the subsequent call to the previous would return the new element next. So after you do the addition, if you do next, it's not gonna be affected, but if you do previous, it's gonna be returning the new element. This call increases by 1, the value that would be returning by a call to the next index or previous index. So here it is. If we would add 33 in here, it's gonna be, so has next returns true, has previous returns true. Okay, then we are going to put the 33 inside or the list in between the 5 and the 22. So we're trying to add 33 and the iterator was in here, so that puts it inside the list in between 5 and 22. And that's it. So remove removes from the underlying collection the last element returned by this iterator. And again, this is optional operation if you don't want to have it. This method can be called only once per call to next or previous. The behavior of an iterator is unspecified if the underlying collection is modified while the iteration is in progress in any way other than by calling this method. So if you did something other than calling remove and that thing you have done removed an element, the behavior of an iterator is unspecified. So previous just returned 22 and the iterator moved. So has next returned true and has previous returned true. So if I'm going to remove, then 22 is going to be removed. The 22 is going to be removed because the pointer is in here, and if I do remove, then this 22 is going to be removed, and now 5 points to 12. 5 becomes pointing to 12, 22 is gone. You can return the element if your function is not a void function, if remove is not a void function, and this function is void, so you don't have to return anything. But if you can modify function or overload the remove function and make it return the data inside if you want. So the iterable interface, it contains a method named iterator and it returns iterator. As you can see, we used collections before, right? And we used list. Both are extending the iterable interface. So hence any class that implements iterable will return an iterator. Many built-in classes implement this interface. So this is interface that extends this interface. We have something like that. So interfaces are not implementing each other, but they're extending each other. So the iterable interface is an interface that has this signature. Public interface collection extends iterable interface. This interface is extending this interface. A collection is an interface that represents a container for a series of elements. Right? You have seen this before when we used it to sort array lists. So basically, what is the difference between the iterable and iterator? So an iterable is a simple representation of a series of elements that can be iterated over. An iterator is the object with the iteration state. The iterable does not have any iteration state, such as current element, but this one is the object with the iterator state. These are the main differences. Also, since the iterable does not have current element, it has one method that produces an iterator. And the iterator lets you check if it has more elements using hasNext, and moves to the next element by using next, and removes the current element by using remove, and so on. So this is basically our lecture today. I just want to show you iterator versus iterable and how we are actually doing them, if we are using them, and how they actually act if they were used on a linked list. And that's it for today. See you on the next one.